Hi, everyone. Thank you so much for coming to our presentation today, oh, sorry. As Vanessa said, my name is Quinn Lee. I'm from the University of Illinois, Chicago.
Hi, everyone. Good morning. Thank you for joining us. My name is Natalie, and I'm from Montreal, McGill University. So I'll be giving the first part of our working group update. So this is our working group. We're a small but mighty group, I would say. Here I have included our demographic locations. So representing Canada, there's me, Genevieve, and Jason, who used to be at McGill, but is now in South Korea working at Celtron. And then we have representing USA, Quinn, Corinne, who is our board liaison. And then we have Kristen, Mike, and Andy. And then for Mexico, we have Alexis, Selena, and Diana. And there will be more Mexico representatives joining us soon, thanks to Mariana from the DEI working group, who's been making a lot of introductions for us. Okay. And we're also open to more people joining. So if any of you have students, postdocs, or early career scientists you want to introduce to us, we're very happy for that. And if there are people who are not considering themselves early career scientists and also want to give us some suggestions and collaborate with us, we're happy to talk and discuss those too. Our early career working group, our mission statement is really, we're committed to empowering students. So undergraduate, graduate, postdocs, recent graduates, and any emerging professionals to excel in their careers within the bioimaging sector. So we've really made our group very broad, and the definition of an early career scientist very, very broad. So to kick off, we started this group only a year ago, and that was in the initial talk. So I would say that we got a team come together pretty quickly. And then right in November, we started with a community conversation where we wanted to get to know who would be interested in this group and what would they be interested in us tackling, and like the topics that they want to hear about. So out of the 61 responses from our survey, you can see here that most are undergraduate and graduate students. And then out of the topics, there was a really wide range of topics that they wanted to hear. Specifically, I would say industry job applications and mentorship connections and best practices in microscopy being the major topics. So I'll let Quinn take over talking about what we did tackling those.
Right. So hearing the audience feedback or our poll takers feedback, we try to curate our workshops since our kickoff to meet the needs of people in their early career stage. So one of the first things that we organized, which was led by our working group member, Mike Nelson, in collaboration with Corp Limi, we had a best figure making practices seminar, which was really great turnout. And it was really wonderful to hear Christopher, Yen, and Mike talk about, things to keep in mind when making a manuscript, and also tools on Fiji when they think about the paper process. To focus more on the professional development side, in collaboration with Ellen Dobson, Andy Stone of the Early Career Working Group organized a How to Get Hired networking and resume workshop. So this was about a month ago, and there was, again, a really great turnout. And it was a really interesting seminar dedicated to helping early career stage trainees and people who are thinking about transitioning their jobs to cater their resume towards microscopy-related careers. Focusing more on our future directions. So we've been very fortunate that our working group members are very passionate and are very involved with the activities of the group. And so, as I already mentioned, we already had our working group members taking the lead on organizing specific seminars and workshops. And here are some of the other things that we have ongoing or that we plan to start. So we plan on having a speaker and workshop series. So our approach that we want for this series is to organize our talks into 3 separate buckets. So have invited speakers to talk about their career journeys, of which today's invited guests will be talking a little bit about that. We will also have a focus on soft skills, including similar to our how to get hired workshops. So other topics include like finding the right mentor or how to network. And then we'll also have another bucket dedicated towards technical skills or technical skill development, similar to our best practice making workshop. So this could include, an image analysis 101 class or how to have proper controls. We also, with being led by our working group member, Genevieve, we plan to start creating a resource dedicated towards microscopists who want to learn how to code or how to troubleshoot. So we have a resource project that's ongoing there. And Alexis from UNAM has plans to kickstart a new network of young microscopists of America, dedicated more towards the technical aspects and providing a sort of organization or community, particularly young scientists in Latin America. And then finally, we have plans to start a micro certification program. So this is very early in the very inkling stage or brainstorming stage. I think that not only would this micro certification program be great for early career scientists to sort of verify or validate their work and also demonstrate their core competency, but I think we've listened a lot to the different Q&A sessions from the past week about it's not just early career scientists that can benefit from this program, but also core directors as well. So ways to fill in the gaps and learn specific skills such as confocal or turf. So that's our plans or initiatives moving forward. And then, as Natalie already mentioned, we are always interested in new members. So if you're, want to learn more or talk to us, here are our emails provided. And so I think that's everything. So thank you so much. Right, so we've, from this past week, we've heard from so many great people at the BINA Community Congress and also got to hear about their careers. And as part of the Early Career Working Group, we wanted to provide a platform to hear from fellow scientists and microscopists about their career paths beyond academia. So first, I'll very happy to introduce Ryan T. Scott, a scientist with KBR and the NASA Open Science Data Repository, with a presentation titled Spaceflight Biosciences, Data and Open Science. Thank you.
Thank you so much, Natalie, Quinn, Vanessa. Hi, everyone. I'm Ryan Scott. I really wish I could be there with you all today. I did try, but it just wasn't in the cards. So I'm really grateful to have this virtual opportunity. I'm based out of Bay Area, California, but a lot of our team is based around the country in the U.S. And I do want to have a quick disclaimer. I'm not speaking on behalf of the federal agency, NASA. I am speaking to you today as a scientific citizen and grateful to connect with BINA at any chance I get. And I'll explain why NASA is deeply, deeply interested in imaging soon. So because today's focus is really on sort of career development, I do want to just give a whirlwind of my background. So I grew up I was a military brat, for some of you that know that term, meaning I've lived many, many, many places with my dad, who was in the Air Force for a long, long time. And my granddad was in the Air Force. And so astronauts were always some of my sort of heroes growing up, looking to. As I matured, I got really into reading and funk music and Afrofuturism, from George Clinton to Parliament Funkadelic, Jimi Hendrix. Long story that sort of inspired me towards space. When I was in school, I studied exercise science, biomechanics, exercise physiology. Then I had the honor to be trained to be a human anatomy and physiology teacher at San Jose State, where I taught, 1,500 students over the course of 5 years, which I think was quite important actually for my long-term broad education, to be honest. But my grad work itself was focusing on bones and space health. So we did mechanical testing, we did microscopy, we did micro CT for the morphology, as well as some different endocrine and cellular assays, looking at bone health in space, in rodents predominantly. And then I had an opportunity to join a project where I was part of the science team that sent the rodents to the International Space Station, where I was part of helping conducting 4 different missions where the mice live on the space station for 4 years and are handled and have various different experiments to try to understand the fundamental biology in spaceflight. Then I had the opportunity to join a lab where we focused on female reproductive health and endocrinology, which was probably my deepest foray into the imaging sector field, where that's where I first began. This is 2016, where I was following ImageNet and deep learning and all the different tools. And that's where my first experiment, where we took some of the estrous cycle vaginal lavage cellular images and trained an ImageNet to try to identify cells. I then went and worked on a biospecimen repository called NBISC, the NASA Biological Institutional Scientific Collection. Sorry for NASA's acronyms, but it's pretty much a biorepository of stored tissues that are available for anyone in the world to request tissues and do assays to try to figure out interesting spaceflight results. They're all completely open, and if awarded, they're free as long as you can handle the cost. Then I had this wonderful opportunity to join the Ames Life Sciences Data Archive. I couldn't believe my luck. I think this was a little bit before data became such a big deal several years ago. And so as part of ALSDA, we took a older archive, which was responsible not for molecular omics data, but imaging, physiology, environmental telemetry. And I was part of the effort as the project scientist to modernize ALSDA, which then we formed a working group of now close to 300 people in the ALSDA analysis working group. And since 2021, we've been developing many different metadata as well as formatting standards. And that's where I've been so keen to try to learn from Bioimaging North America, Quadrep Limi, IDR, Bioimage Archive, EBI, to try to learn as much about the various different standards for imaging related data from you all. And then a lot of the purpose of this is not only to figure out ingestion standards, it's also to figure out standards for egress of data. So, we have this whole working group that now that they've helped determine the various standards, they help then collaborate and publish. So I've been involved in a lot of different efforts to make sure we can get the data out. For example, this past June, we had a package of 45 articles across Nature portfolio, 15 of which came through this, the broader 800-person analysis working group that's around the Open Science Data Repository, which is next. Vanessa, or someone, can you? I've realized now I wasn't paying attention to time very well. Could someone give me a time check?
We've got about 4 more minutes. 5
Oh,
more minutes.
perfect. Yeah. There's only a couple slides. So part of the reason data is so crucial for spaceflight. So my big thing is that NASA is also very conscious that instead of just watching the next moon landing or watching future Mars missions, open science is an avenue to enable the ability for people to participate, right? So, like, for example, we're quite conscious that some of the earlier images that are going to come from the moon are going to be imaging from, let's say, plants. And so we'll have be it morphometric photography. There could be other different imaging modalities, which we're going to get data and probably sequencing data back from the moon, so that people are actually going to be able to engage open access wise in science rather than just watching moon landing. So knowledge discovery, enabling informatics, taking the data from spaceflight so that we can look across hazards, look across missions, look across species, look across multimodal types. So it could be imaging, it could be tabular results, it could be sequencing data, it could be telemetry data, both sort of controlled, hypothesis-driven, but also biomonitoring longitudinal data types, having data so that we can have these novel ecosystems be developed, countermeasure development, and above all, we want to make sure we get the data structured in a way so that it involves the world in space, and that the data, you can have trust and confidence in the quality. And so we go to great measures to work on that. So this is the repository that I work for. It's called the NASA Open Science Data Repository. In the last few years, we've federated between the Ames Life Science Data Archive, NASA Gene Lab, and that biorepository that I mentioned earlier. And it's a way so that we have over 500 studies of data. Like even this couple days ago, we released 2 data sets connected with atomic force microscopy, for example, both raw, processed, both the mechanical properties, but also the imaging connected to it. And these are just some of the aspects of our repository that we work with principal investigators that have to submit their data. And we also work with the community on getting maximal access as well as an API. And then we have the beautiful thing about standardizing all these data is then you can build various different analytical and visualization tools on top of the repository, which we're quite proud of. So this is a little bit of a snapshot of that working group that I was talking about. We're just over 700, we're closer to 800 people now. And it's split it up into various different subgroups. And they help us provide feedback both on ingress of data and egress of data. And I'm deeply honored that we've had about 90 publications of scientists and people mining our data coming out of the repository, which I'm quite proud of. So yeah, I can also answer questions towards the end. I think we're going to save the questions towards the end, but yeah, for everything from my day-to-day, it differs. I'm sort of like dancing on the edge of being management, but also in the trenches, just getting work done, because it takes a lot to crunch data and clean data and then follow our sort of verification validation process to make sure that every single atomic force microscopy data set is identical, so that in the future that the data can actually be mined with apples to apples, right? So we go through pretty great lengths to make sure our processing of all of our data sets are in standardized pipelines. At the same time, I'm actually the point of contact for all analysis working group members. We like it in imaging. We actually had a whole proposal plan to modernize and learn from you all, the imaging experts, but we had to put a pause. There are budgetary limitations that were controlled by forces beyond us, and but we do have making it as much as our imaging data even more accessible according to some of the current standards, hopefully soon. So yeah, thank you so much. It's an honor to be with you all virtually today, and I hope to see you more people in person in the future.
Thank you, Ryan. Next, I wanted to introduce Rita Strack, Senior Editor with Nature Methods, with the presentation titled A Professional Editing Career.
I want that guy's job. But you guys have to spend the next few minutes hearing about my different and cool job. Oh, that is loud. Okay. Yeah, I did not put my title on this title slide for some reason, but yes, I'm going to talk to you about a career as a professional editor at a research journal. And I'm at Nature Methods in particular, and I've been at the journal for 10 years. This is our 20-year anniversary, so I have been handling microscopy for half the life of the journal, which is sort of a humbling statistic for me, but it's been a really fun ride. So we were asked to start with a little bit of our background. So I am from the Midwest, not too different from maybe life in Madison, Wisconsin. I went to high school in Indiana. I always had a love for STEM fields. I loved math and science, especially biology, but much to the dismay of my tiger mom, I had no stomach for medicine. So I think MD was just off the cards from the outset. I can't even see like a mouse brain surgery without going, ooh, right? So that's still me. So I went to a small prestigious engineering college in Indiana called Rose-Hulman Institute of Technology, but I was very stubborn. I did not do engineering there. I double majored in applied biology and biochemistry, and I actually took so many literature classes that I was granted a minor in literature. And that didn't mean much to me at the time, but I think it's funny that I came to a job that is so focused on the written word and about science communication. And I think that sort of circles back to my love of the written word. So when I was in college, I had these opportunities to do 3 REUs, which are like research experience for undergrad. And I did one in genetics, one in molecular biology, and one in biochemistry. And I loved biochemistry. It was like an instant click. So that helped me decide what I wanted to do in graduate school. I went to the University of Chicago, where I got my PhD in biochemistry and molecular biology. And you guys can work backwards how old I am, because I graduated college in 2005 and I got my PhD in 2010. I worked with Ben Glick and Bob Keenan, studying and engineering the red fluorescent protein DS-Red. I studied the chemical mechanism of chromophore formation, and I made proteins you may have even used, E2 crimson, DS-Red Express 2, DS-Red Max. Those are some of my babies. so maybe my hands have been in your experiments. And that's where I really learned that I love spectroscopy, I love microscopy, I love probes. I did my postdoc at Weill Cornell in Manhattan with Sami Jaffrey, where I developed these small tags. They're called spinaches, and they're RNA mimics of GFP for imaging RNAs in live cells. And this is not to brag about myself, because this is sort of ancient history now, but I was good at science. I had 6 first author papers. 3 of those were in Nature Methods. I wrote reviews. I had my postdoc fully funded, things like this. I had a good traditional sort of conventional academic CV. And I was on sort of a traditional academic track. When I was on the job market, I applied to 11 schools and got 6 interviews. 2 of those schools actually recruited me to apply. They said, Rita, can you please apply to our next job cycle? So I think I had good chances of doing sort of the normal thing, the traditional thing. And again, this is not to brag about myself, because a lot of people go this route, but it's just to sort of dispel this notion that if you leave academia, you're a failed scientist or you couldn't have cut it in some way. And I think that's sort of a feeling that has lingered around editorial careers. And I just want to dispel that myth. There's definitely an alternative universe where I'm in the audience in sort of a different capacity. But especially for the students and early career people in the room, there are lots of jobs. And you should try to know yourself, know your personality type, know what makes you happy, and choose accordingly. And I think if you're happy in your work, there's no such thing as a failed scientist. You use your training in every aspect of your life. So let's see. So I was on the academic job market, had sort of grown up with that mindset. And I was excited about the possibility of pursuing my own questions. I thought I had a very good research packet. I also had a newborn baby. And having him, my son Quentin, it really changed my view on what I wanted the future of my life to look like, especially with work-life balance. Work-life balance is something I never cared about for a single moment until the moment my son was born. Before that, it was work-work balance. I would wake up thinking about work. I would go to sleep thinking about work. So that sort of mattered to me in a way that it never did before. I also wanted to stay in New York City. My husband, of course, he's fully remote now because of COVID, but at that time he had a great job. He wanted to stay in the city, so I wanted to stay too. And I think this blue point is maybe the most critical in the whole talk, is that I knew I could be happy doing something else. I worked with a whole cohort of people who could not be happy doing anything else except running their own lab, but I was not in that little group. So I sort of cast a wide net when I was applying, and I found this position at Nature Methods, and it sort of worked out really well for me. So I think when you're thinking about what you want to do in the future, you have to just sit with yourself and think, what do I want from my life? You know, you want a job. I wanted a job that uses my skills and training, that keeps me interested. I'm a very curious person. I like to be mentally engaged and stimulated. I wanted to stay in the scientific community. I wasn't sick of it. I didn't want to leave science altogether. I wanted to do work that I think is important, have a good work environment. Again, conventional work hours became important to me in a way that it never was before. And I think this is pretty typical. You know, nobody wants a dead-end job, right? I wanted the potential for upward mobility. And so I think being an editor checks all of these boxes. So what is I don't want to just talk about myself. I want to tell you guys what a professional editor does. And this is sort of like the nuts and bolts. So Nature portfolio journals, certainly Nature Methods, we consider the journal to have 2 portions. There's the research portion of the journal where we publish cutting-edge technologies. And for that, we do things like read and evaluate new manuscripts. I handle about 10 new papers a week. In my career, I have read over 5,000 submitted manuscripts. So people ask, Rita, how do you understand trends? How do you know so much about different areas? It's like, I'm just reading the literature. I challenge anyone with a PhD to read 500 papers a year in detail and not learn about the scientific space, right? You can't not do it. So that's a big part of my job. I assign peer reviewers. I evaluate reviews. I correspond with authors and reviewers. This is a very people-facing job, but I think that aspect is not always appreciated. And I see papers through revisions and ideally through acceptance. We also have the magazine portion of the journal where we publish reviews, news and opinions and comments. And for that, we do a lot of writing. We write things like editorials, research highlights, research highlights, methods to watch, things like this. We do a huge amount of commissioning and editing of reviews, news and opinion comments. And I just wanted to show this focus issue. This was entirely my brainchild. I commissioned all of the comments in this piece. I did developmental editing on all of the comments in this piece. And I think it really came together beautifully. And so this is the sort of original thinking you can do as an editor, and you can create things that serve the community. Of course, in conjunction with the scientists who are doing the work, right? So we do a lot of that, and we attend conferences and do lab visits and occasionally give talks. So that's sort of, again, nuts and bolts view. We do a lot of things that keep the job interesting and fun. I think an important part of our job is to make the publication process good for our authors. We want people to want to submit to us. We want the process to be good for you. So how I think of my job is the second point. So a lot of people say, oh, the editors and reviewers are trying to make this paper into a totally different paper or to tack on a second paper. So I have the opposite thought of that. If the paper is not in a good enough form that it can be slightly modified and we can publish it, so I'm not making the paper I get into a Nature Methods paper, we just reject. I want that paper as the best version of itself. That's the focus of that's how I'm thinking about a paper when I put it through peer review. So I want to take a paper in the version we get, make it a Nature Methods paper. An important part of our job is to give scientific and editorial feedback on ongoing research and the papers that are submitted to us. I've had scientific conversations already with many of you in this room, and if not this meeting, then before this. So I think we've all experienced that. An important part of my job is to interact extensively with the communities. I hope that I'm a known entity, that you guys feel like you can communicate with me, you feel like you can reach out to me to talk about the journal, talk about science, pitch papers, etc. A big part of our job is recruiting the most exciting content. We want the journal to be good. We want people to read it. And then we do a lot of work sort of behind the scenes to improve the journal. And we want to improve scientific publication. Can we make it faster, more transparent, more robust, more reproducible? Are there ways we can do that through the journal? Very often, yes. And are there ways we can improve science more broadly? Can we make it more diverse, more fair, more equitable? And when the answers are yes, we really try to take steps in that direction. And that is sort of what keeps the job fun. And I wanted to say here that we're a small team. There are 7 editors at Nature Methods. And we are fully responsible for the scientific vision of the journal. And that's like a privilege and a burden. And so we take that really, really seriously when it comes to everything we commission, everything we publish. And we have this very high commitment to quality. And ultimately, we're trying to create this curated product that we hope people love to read. So there are a lot of great things about this job. For me, it's really exciting to read cutting edge research. I'm naturally optimistic. And when I see what you guys are doing, and you guys continue to surprise me every day, every week, I'm like, yes, the future is bright. So to me, that's a really fun part of this job. We have the ability to shape research trends or to shine light on certain ideas or areas of research. It's very satisfying to see a paper in the form we get it become a Nature Methods paper and be published. And then to see those methods start to be used broadly by the community, that's like super satisfying. We also do a lot of different things. It's not a very one-note job. We're busy and we do different things. We get to travel. This year alone, I've been to Beijing, Portugal, Madison, Wisconsin, all the beautiful places in the world. And I get to talk to science. I get to network. I get to meet a lot of wonderful people. It's a great work-life balance. I work exactly 40 hours a week, and I'm productive and I'm very good at my job. And I typically don't fall asleep thinking about my work. So I mean, when I was leaving the bench, I actually felt like it was greedy to want that. Like, I can't believe I would want just a normal working life, because I was very different from how I thought as a bench scientist. But ultimately, it's been really good for myself and good for my family, and I still have a very satisfying career. It's a stepping stone to a bunch of different careers. You'll see former editors doing all sorts of things inside and outside academia. And you get to, this is a big point, I think, for everyone I know who's an editor. You get to stay in science, still do scientific thinking, still use all your training, but no bench work. We certainly have highs and lows, stresses, setbacks, but there's very little failure in this job. And depending on what type of research you do, that can be very freeing, right? To have that feeling that you're always moving forward. There are lows. So the hardest part of my job is rejecting papers by far. I have done this job 10 years. The pain never goes away. Every single time I send a reject decision, I'm like, ooh, that sucks. I think the good side of that is that I'm always careful. I'm never flippant about sending a rejection. I'm always very aware that there are real humans receiving that decision. And what I want to tell students especially is that I'm making a very specific decision on a paper, whether or not it's a good fit for nature methods. I am not saying the paper is not good. I am not saying the paper should not be published anywhere. I'm not making a general quality statement. I'm making a very small assessment. Nature methods, not nature methods. So when you get a rejection, I hope you can put it in that context, because the papers, our cup overfloweth. We reject 90% of our papers. So it's not a quality statement, absolutely. Okay. So I borrowed this slide from my boss, and she put the problem reviewer slide on here. I don't have problem reviewers, except the problem is ghosting. So if you say you're going to review, please do it. And if you find you can't, just email me as soon as you know, because there are authors waiting on you, right? And sometimes we've delayed the process up to a month to wait on a person who's ultimately just never going to submit. So just do everyone a favor, do your colleagues a favor, and just say, like, you know what? There's too much on my plate. I cannot look at that. And that will give me time to quickly say, oh, please, Kevin, could you please just give me a quick opinion on this paper in 1 week, because I need a third reviewer, right? That'll let me make the process as fair as possible for my authors in as fast of a time as possible. We make a lot of decisions. Decision fatigue can be an issue. We manage a high workload, and we have deadlines. We have a monthly issue cycle, so we need things done regular. I put travel as a perk. I love traveling, but it can also be hard when you have young kids. A nice thing is it's flexible. When my kids were very young, I didn't travel much, or I traveled very locally, sort of in the Northeast. And now they're older and I can travel away from home. It's a desk job. That's not appealing to some people. And this is not entirely true, but most people don't leave academia, become an editor for a while, and then jump back into, say, like an assistant professorship position. That's not a typical trajectory. It's not impossible. But that's not what I've seen my colleagues do. And then how much do we get paid? If I left my job now and went to consulting, 1 minute? We're overtime? Oh my God. Okay. Oh my gosh. Okay. Let me see. So there's just one important point to this slide, which is if you want to be an editor, start early, because very often the ad is searching for specific scientific expertise, and it allows you to cast a wider net. And I wanted to stress specifically that we don't have internships, at least not at Nature Portfolio, but we do have what's called a locum. This is a 6-month position. I think this is a Britishism for a temp, but basically it's a maternity family leave cover. It's a 6-month position. You jump into the role. You get a lot of babysitting and handholding, but you are an editor immediately in that position, and you can learn if you like it. And 100% of the locums I've worked with in my 10 years who have wanted to stay in the company have stayed in the company and become full-time editors. Okay, we can talk about these other details later. Okay, so sorry, I'm so sorry. I didn't mean to go over. I talked too much about myself.
Thank you so much, Rita. Next, I want to introduce Manish Arora, the founder and CEO of LFS, with the presentation title, My Journey to Imaging.
Okay. Thank you so much for having me. And I'm a little older. You'll guess my age as I walk through my journey. And so I'll start it with, for those of you that are old enough, and now for something completely different. I could never dream to do what many of you have done with a science background. I have not a science background. So I'll tell you a little bit about myself. I was born in India. I grew up in New York. And the one thing that I was confident about was that I wanted nothing to do with science. I was really good at math. And so I divide my life journey so far into 4 phases. And I'll talk about each of them so you get a sense for my journey to imaging, which I absolutely believe in and have invested a lot in and learned a lot about. The first part of my journey, I would say, is ages 0 to 30, where I was born in India, grew up in New York, and I went to school. I went to school for economics to the University of Chicago, came to Chicago, and I was forced to take science classes, and it was kind of interesting, but I really wanted to be a business person. So I graduated and I went into industry, and I was good, and I knew that I needed to be leading things, and so I went and got my MBA. I went to Northwestern, got my MBA, and then about 10 years into my career, and I'm not going to put up dates yet, but it's a little longer, right? My dad got really ill, and I got a first-line look at the healthcare system, and I was in consumer packaged goods, and I said, this isn't fulfilling for me. And that's going to be a theme that I'll bring back about things that resonate with you. This is a career talk, so I'm talking about my career. Every journey is different. My journey is not typical. It is different, but I got to take control of it. And that's going to be another theme, is the message to all of you, no matter where you are, take control of the journey based on what you feel and what resonates with you. So I hit this point where I knew that I wasn't going to be doing something that wasn't involved in healthcare. And I had this unique opportunity. I was in the Chicago area going to school. Ironically, met a girl in school that was a science girl and went on to get her PhD, was at Argonne National Labs. And so I got to view of the other side and got a job because we have this unbelievable community. I live here in Madison, of a university with unbelievable science that comes out. When you have researchers and scientists, the one thing that the coasts do a better job of, but that Madison started to do, was started to spin out companies. And there was a really awesome company that spun out of the University of Wisconsin-Madison, Jim Dahlberg and Lloyd Smith, called Third Wave Technologies, that went public. And I was this business guy that wanted to get into science. I made that conscious choice and they took a chance on me. And so I started commuting and I was like, wow, this is a really good community. And I knew that I wanted to be in cancer. We all have our own decisions, our own journeys. It impacted my life. And so got actively into cancer on the company side and was in management, learned a lot about science along the way, and built the second to market test for human papillomavirus, cervical cancer screening test that was acquired in 2008. And so now I'm in Madison, Wisconsin. And so we took a flyer on a company to screen for colon cancer and brought this company from Boston to Madison. And I was fortunate enough to help start a company here in town called Exact Sciences to try and screen for colon cancer non-invasively. And again, given the privilege of helping to learn about the science, build and grow. And that actually was chapter 1 was my move at Third Wave. 1 was growing up, moved to Third Wave. Chapter 2 was this journey around Exact Sciences. And so it taught me a lot. We were able to build this great product, but it actually was a precursor to my move into imaging. One of the things we were trying to do at Exact was trying to build additional tests for cancer screening. So one of the journeys that I took was to Mayo Clinic. We were working very closely with Mayo Clinic and went and talked to the clinicians and said, what if we come up with a molecular signature for pancreatic cancer? And the one thing they said, talking to the physicians and the clinicians, was, okay, that's great, but if I can't see it, there's nothing I can do about it. And that thought really resonated with me. And it underscored the importance of not just the genetic side of things, but the ability clinically to visualize results. And that really led to, at the end of my Exact journey, I did that for about 10 years, I started to figure out what was next for me. And that really was where I got introduced to by Rock Mackey, to Kevin Al-Siri and others. And the idea that I had was, I am not a scientist by training, but I can understand how do you apply those things to things that will be useful for patients. And that's the connection role that I play. That's my career journey. And the thing that I get motivated by is, can I understand and work about enough on the science side, not for the sake of the technology itself, not for the publication, but rather for the application? And can we take these great innovations and transform them to things that will be useful for patients? The analogy that I use as the layperson is, I don't know anything about microwave radiation technology, but I know that if my food is cold, I can go to the kitchen and press a button and it'll warm up my food. Is there a way, and the idea was, is there a way to take this unbelievable multiphoton microscopy advances that have happened in imaging across OCT, across multiphoton, and marry it back with the message that I got from the clinicians that said, I really need to see it in order to do something with it. And so that's kind of the career journey. So what did I do? I said, okay, well, I'm here. I'm going to try to take advantage and have been fortunate enough over the last 4 years to build a company called Elephas with a single mission. Is can you use advanced imaging to build a platform to predict response to immunotherapy? So I'll take a step back. What problem are we trying to solve? Immunotherapy in cancer, I'm in oncology diagnostics for the better part of my entire career. Immunotherapies, drugs like Keytruda, Opdivo, Yervoy, have absolutely transformed cancer care over the last decade. Why? Because they have the potential to be curative, to activate your own cells to fight your cancer. It's amazing. The problem is we're spending hundreds of millions of dollars on these great things, but there are no tools to guide their use. 4 out of 5 people that take Keytruda don't respond. And with all these immunotherapies coming to market, that was the big opportunity, and that's really why Elephas was founded. The reason that I knew the traditional approaches hadn't worked, and the only solution that I believed would work would be imaging. Problem? I didn't know a lot about that. And so the good news and the differential path of my journey was trying to connect the dots between the application and the science. And so was able to bring together a lot of folks from here in Madison, folks with biomedical engineering backgrounds, people with immunology backgrounds, but really with the goal of bringing these things and disciplines together. We have been fortunate so far in developing this. We've got about 90 employees on the west side of town. We've raised about $125 million. Why? Because the problem we're trying to solve for is enormous. And so we're building an imaging platform. We built it kind of from the ground up to solve not just for the technology, but for this problem. This is a career talk. That's my career journey. It is a little unorthodox, but it is heavily centered in imaging. Why? Because that is going to be the future. What you all are working on is going to be the future. And what advice would I give you? I would give you the advice of you get to take control of your career. And there, as I think Rita did a great job mentioning, there's plenty outside of and beyond the lab. And as a commercial person, just make sure you enjoy what you do. Right? I'm not going to subscribe to the work-life balance. I haven't quite figured that out yet. But you get to decide what you want to do. And there are tons of things to be done in your career and tons of opportunities to solve problems with a different bent than just research, with practical applications. So you just have to go back and figure out what does that mean to you? And the world is your oyster. There are so many companies, you can see them out there, working on applications, working on technologies, and those are incredibly fulfilling jobs and careers. My advice to you and my advice to myself would be just make sure you enjoy what you're working on. You're fulfilled. You can clearly see it in Rita. She's really fulfilled and just picked the right things for her. Make sure that you enjoy what you do. And that would be my best advice to you from a career standpoint. Thank you so much for having me and happy to take questions.
I wanted to thank all of the invited guests today for sharing their career journey. If we could have another round of applause for all of our speakers today. And so we'll start off our Q&A section. We have one right there. Right. And then
And Ryan, if you want to turn on your camera, we can see you in the room. If you can join the panel.
Thank you to all the speakers. So this is oriented towards all the speakers. I'm here. So one thing that we also often as a company think about, so Nicolas from SVI Huygens, is, is it necessary for people to have the PhD to get a job or to get what kind of job? And especially considering, when you're a young person and maybe you're like in your mid-20s and you're ready to have kids, you can't really combine that very well with having a PhD. And that is, more so for women than for men, but it holds for both. And I feel there's like a tension there that like, yeah, maybe you'd like to have kids, but maybe you'd like to have a PhD, and what to do there. And like one practical thing is, as employers, we can hire people with a master's. And what career opportunities do you have with a master's degree?
Yeah, I can answer that quickly. So at Nature Portfolio, all of our professional editors have a PhD. And I think you just need that level of training to think about science the way we think about science. Most of us have also done a postdoc, but that's not strictly true. So yeah, the way we think about science, the technical expertise we have to have, I think a PhD is really just crucial for that. And also, a big part of our job is to build an editorial board in which authors and scientists have trust. And I think part of that is having the training to back that up. Yes, but I think work-life balance and balancing children at any career stage, that is a huge challenge that academia, that everybody, a lot of people struggle with, that academia has not solved very adequately.
So I would say it depends on what you want. If you want a job as an editor, you're going to need a PhD. If you want a job at Elephas, you absolutely don't. And so I think that, early on, we needed more PhDs. At the stage that we're at now, we probably don't need more PhDs and would rather have biomedical undergrads, and we would rather have master's students. But the goal is different. And what I have found is that sometimes aligns almost better with the commercial goals of a company. I was having a conversation earlier this morning, and the shift from academia to a company is really different in that we're not trying to get that best paper. So the example I'll use is, we have jihad fights about should I use a water lens or not? Well, I can't commercialize that and get a reproducible result. So if you want to write it for a Nature paper, well, yeah, but for us, you don't need that. So the objectives are different. So depending upon what you want, I think there are a ton of opportunities for both undergrad and master's students. You just got to make that choice.
Maybe I'll just chime in here. I don't have a PhD, but the rest of my team does. So I think I just got in a weird time. I think it was probably mostly luck. So I probably should have it, which keeps coming up. But I always said that, like, if I'm stopped being productive at NASA, then I'll go back and get a PhD. But for now, I'm staying productive and useful. So yeah, I will say that I remember I'm a contractor, so it is yeah, it's so NASA has, gosh, it's a tricky question. I don't know how blunt to be.
He's basically saying you need a PhD.
Yeah. At the same time, it's interesting because NASA is becoming more and more involved in managing different missions rather than driving a lot of missions, especially with the commercial space flight, thinking about SpaceX missions and Blue Origin. It's a tricky question. If anyone's interested, they're more than welcome to reach out to me. I try to get back as soon as to help answer these questions. So, but yeah, my curation team, right? Everyone, 4 of them have their PhD. Of those, two also had a postdocs, right? So they chose because they understood this data was crucial to have that career. So yeah.
Hi, Eric here. I think one thing is that a lot of these positions will require research experience, right? And it's hard to get that lab time if you are not doing a grad degree. I think that's the difficult part. But for example, I have someone in my team who only has a bachelor's degree, but spent 5 years as an RA in a lab, right? And she had the computational skills to do the things we needed her to do, and we hired her even though she doesn't even have a master's degree. So I think it's just a matter of how do we get people to have research experience without having the PhD degree necessarily. But the actual thing I wanted to get to is that I'm also in that very like support kind of position, right? Where my job is to make everyone's science better instead of doing the science myself. And I think that's very fulfilling, even for someone that's very like idealistic and very like, I just want to do good research, right? And it can be more fulfilling than actually being a PI, actually being on the lab. And I think that's something that's hard to convey to people who are coming up and doing a PhD and wanting to, you know, improve the world in a sense, like do science and do something good. How do we bridge that gap, right? Like how do we convey to people that sometimes it, like, just for example, Rita, you touch like hundreds of like research from hundreds of groups around the world, right? And you make everyone's research better to a certain degree, right? And it's something I do as well. How do we put that to people, right? How do we tell people that this is also a thing you can do that will actually make science better?
Can take a first step at that. I think this is actually changing. I am invited a lot to give career talks at universities for undergrads and graduate students. And these are career talks that I never experienced. They were not given to me. So, you know, things are changing where exposure to different types of career opportunities and what's out there as a possibility is growing. And I think just in the last 10 years, I've seen this huge rise in the imaging scientist as a career, right? And obviously many of the people in this audience are imaging scientists. And so I think these sorts of very scientific, very viable, very satisfying, interesting, engaging jobs, the number of them are growing. So we need to just make people know what the jobs are, what it actually entails, and the ways in which they are satisfying and the ways in which they are frustrating, and just sort of be honest and out there about it. That's the only thing I can think is just to make more people aware of the possibilities, because certainly at the University of Chicago, everyone was very academic minded. There was basically one trajectory for us, one successful trajectory for us, right? And I think that's changing now because they have like this My Choice seminar series, and I've been invited to speak as an alum. And so I hope it's changing, because I totally agree with you. There are many satisfying ways to do science that's not just being a PI.
I have a question.
Sorry, we have a question from our audience. Jose asked, what were your biggest challenges when changing fields, and how did you all manage to leverage your previous experiences?
So I'll take a quick stab. I changed fields. You can see it, and there's no shortcut to the elbow grease. There's no shortcut to the late night reading. There's no shortcut to the work and learning, and that pays off, right? So I don't have a different answer because I don't know that there is one. You have to have the desire and the willingness to put in the work. And there's nothing that you can't do as an economist that understands a little bit about imaging now, and different forms of imaging. You are all starting with a much, much stronger and better base. So stay after it, do the work.
Yeah, so I sort of stayed in the same field. In fact, my network was big and I just grew it because I stayed in probes, I stayed in microscopy. So I guess I don't have like a super good answer to that. It's just, but be flexible and again, be willing to do the work and be flexible. I did have to trade knowing the most about RNA aptamers, right? Like just knowing absolutely everything about them and being a fluorescent protein expert. I had to trade that, you know, being at the leading edge of one thing for this broad, diverse knowledge that I have now. It's been a satisfying trade, but again, it's on your personality type, if that's the sort of thing you'll like.
And I just have one more add because I didn't address the second half of that. I believe that I am a better and more effective leader by having done the work based on the prior experience. So I absolutely bring to bear the business, the MBA, the ability to connect the market opportunity with the science, which I wouldn't have been able to do had I not had the prior experience. So you absolutely are not a sum of parts. There is synergy as you learn more things to bring to bear everything that you've done prior.
Ryan, do you have anything to add about your biggest challenges when changing fields?
I mean, I think this also slightly ties back to the last question on NASA obviously has a specific mission. So sometimes there's a culture that publishing isn't as important historically for some people. Like both of my bone and female reproductive scientific investigations in grad school were not published, which I don't like that. I even wrote up a manuscript, but it wasn't the priority, right? Like, well, we figured this out. Now we can give feedback to leadership. We'll write a report, and so it's an interesting changing culture where there's some, because the missions is what's critical, and they have different metrics for mission, not necessarily publishing. So it was a tricky sort of navigating that, because at the same time, if I didn't have those articles, and two of them actually I wrote up the manuscript, it just wasn't top of importance. So it was a little tricky managing that. Yeah, but actually I think my broad anatomy and the bone biology training is actually, especially the anatomy, is because like right now I'm just dealing with data standards and metadata standards, and having learned so much about a broad training in anatomy has sort of helped out. But I will say that it's sort of understood that if you're a scientist at NASA, you're expected to write more and more and more. So I'm not very good at work-life balance, to be honest. I like we just said, I sort of go to sleep thinking about it, and I wake up thinking about it, type deal. But so I'm still figuring that side of the house out. But yeah, I don't know if that directly answers, but thank you.
Yep, and then we'll take one more question.
Yeah. Hi, my name is Wihan. I'm a grad student here. So I think probably this question is more suited to Manish, but so in this your hybrid world of business and science, so you come from the business side, and I guess for early career people like who come from more science, what advice you would give to them so that they can adapt to this hybrid world?
The best advice I can give is go immerse yourself in a company rather than academic track, if that's what you want. And so you are going to learn, and what Ryan just said is so relevant. We don't have a ton of publications. We made enormous progress because that's not the goal. We have KPIs and objectives that we need to hit to go build a product. And yes, the publications are important, but they're secondary. And that's a mindset shift. And the only way you can learn about that is by living it in whatever company you go to. Every culture is going to be different, but there's no substitute but getting into that environment.
And maybe a quick follow-up. What role then? Because I think coming from a science background, then naturally, I personally will tend to look for more technical engineering or scientific role. But then because for the business side, I wouldn't know what to look for.
I don't want to monopolize. I want to, So what I would say is you're not going to get a business role generally. And this is terrible of me to say. There is nothing, when you come out fresh, there's no job or experience that is bad. You are going to learn an incredible amount, whether it's quality or operations or R&D. Don't get hung up on that. You get to drive based on your decisions on where you go, but that first year is just flat out learning. So I wouldn't be hung up on the role. I'd be hung up on the right environment and the right company, and you're going to learn in whatever role you get.
Great, thank you.
Great, and so on this note, we have one more question, one last question.
Yeah.
It's not a question, it's a congratulations. This working group was an idea at the meeting in Mexico last year. So I just wanted to congratulate you on all you've done this year and putting together this great session.
I'd like to thank our speakers again, and I wanted to announce that we'll continue, or if you wanted to talk more, we have a lunch networking table. So if you guys had any lingering questions, we can talk more there.